rational number. I really don't want to have to algebraically simplify squaring that and multiplying it by 3 and whatnot. So I'm going to use the God-given technology and come up with a decimal for that, which is going to give me an approximation that we're going to see, is this approximately equal to 1? So if I do -3 plus the square root of 15, and then divide that by 3, I have approximately 0.29. So I'm going to use that decimal approximation. X is approximately 0.29. And now I am going to substitute that into the left-hand side of the equation. I have 3 times 0.29 squared plus 6 times 0.29 minus 1. Okay, so that gives me 0.9923. And I have to decide, well, is that equal to 1? And we knew that we had a rounding error to start off with. We were using a decimal approximation. And so our answer is going to have a rounding error. So is this pretty much 1? I'm going to say yes, it is. And so therefore, this is a real solution to the absolute value quadratic equation. All right, so now I'm going to check x equals -3 minus the square root of 15 all over 3. And again, I want to come up with a decimal approximation. -3 minus the square root of 15 divided by 3 gives me approximately -2.29. All right, so substituting that decimal into the left-hand side of this equation. This is a negative number that I'm substituting inside the parentheses for exponents. So make sure you use your parentheses. All right, so 3 times -2.29 inside parentheses squared plus 6 times -2.29 minus 1 is equal to, again, positive 0.9923. And so just as before, I'm going to say, well, due to the rounding error, this is approximately 1, and yes, this is the solution. Now, what you're boxing in for me is the exact solution in simplest radical, simplest fraction form. You are using an approximation for your convenience to check your work. But the answer that you have to supply to me is the exact answer. All right, so we have 2 more solutions to check. We're going to also check x equals 0, and we're going to check x equals -2. Okay, so I've got 3 times 0 squared plus 6 times 0 minus 1. That gives me a -1. So if I were to take the absolute value of that -1, does that equal +1? And well, yeah, it does. And so therefore, x equals 0 is another true solution to this quadratic equation. I'm going to substitute -2 in. Again, since you're substituting a negative number, especially when exponents are concerned, make sure you substitute it inside parentheses. 3 times -2 squared plus 6 times -2 minus 1. And again, what I have is the absolute value of -1 equals 1. Is that true? Yes, it is. So all 4 solutions were true for this quadratic inequality. I know that you're going to say this is a pain in the neck. You have to do it. Okay, moving on. Here I have found another one for you. Okay. Now I know, because I've done this problem in advance, that this factors very nicely, and so you won't have to deal with those irrational solutions. So I am going to ask you to pause this video, try this problem yourself, and then when you're ready, check to see if your solutions are the same as mine. Okay, welcome back. And here I have my solutions that I've already worked out for you. Again, step one is to rewrite two separate quadratic equations, one where you're setting your equation equal to +4 and the other is equal to -4. Now, these give you two, when you put them in standard form, so I subtracted 4 from both sides for this equation on the left, I added 4 to both sides for the equation on the right. So both of these two quadratic equations are factorable, and these are easy AC, so the problem that I've given you is much easier than the one I already demonstrated. Okay, let's look at the one equation on the left. This is easy AC. I looked for factors of factors of -5, whose sum is +4. And those magic numbers are +5 and -1. So therefore, those two solutions are -5 and +1. On the right-hand side, again, it's easy AC. I'm looking for factors of 3, whose sum is 4. Those magic numbers are 3 and 1. So there it is factored. Here I solved and found x equals -3 and x equals -1. And just like in the previous example,